Hello everyone, in this video I'm going to discuss the topic integration. So here we have the example for area. Sketch the graph of absolute value x minus 3 minus 2. Then express the situation as a sum of two definite integral and hence evaluate it. So meaning that the first step we have to sketch the graph. So before sketch the graph, kindly refers to the definition. The definition for the absolute value would be x and the domain will be x greater equals to 0. And next we have negative x and the domain will be x less than 0. That would be the definition. So kindly define the situation for absolute value x minus 3 minus 2. So x minus 3 minus 2, we will have x minus 3 bracket minus 2 and the domain will be x minus 3 greater equals to 0. Next, negative x minus 3 minus 2 and the domain will be x minus 3 less than 0. So here we have the definition. Simplify the situation. So absolute value for x minus 3 minus 2 is equals to x minus 5 and the domain will be x greater equals to 3. Negative x plus 1, the domain will be x less than 3. So kindly express the situation in a number line. So now here we have the value 3. When x less than 3, the function will be negative x plus 1. If x is greater equals to 3, the function will be x minus 5. When x is equals to 3, the function will be x minus 5. Next, we are going to sketch the graph. So now we have the xy axis. Next, we are going to focus the location of 3. So let's say here will be the 1, 2, and 3. So kindly refers to x less than 3. So we have the function, linear function, negative x plus 1. So kindly substitute the value. When x is equals to 0, the value of y will be equals to 1. So we have the coordinate 0, 1. Next, if the value of x is equals to 2, the value of y will be equals to negative 1. So we will have the coordinate 2, negative 1. Let's focus on the right hand side where the domain is x is greater and equals to 3. If the value of x is equals to 3, the value of y will be equals to negative 2. So we will have the coordinate 3, negative 2. Next, if the value of x is equals to 5, the value of y will be equals to 0. And we will have the coordinate 5, 0. Let's illustrate the situation in a graph. So kindly locate the point in the graph. So we have 0, 1. So where the situation will be here. Next, we have 2, negative 1. Where the situation will be around here. Done. So next, kindly focus on 3, negative 2. So the location will be around here. Next, we have 5, 0. So where we have 4 and then 5. So kindly refers to the situation. Here we have the graph where the function y is equals to x minus 5. For the left hand side, the graph would be y is equals to negative x plus 1. Sketch the graph. Next, express the situation as a sum of two definite integral. So meaning that now we are going to express the situation in the definite integral. So we have a negative 1 until 6. Here we will have 5 and the location of 6 will be around here. So kindly shaded the region. So here will be the region. until 1. And then from the 1 until 3 will be the second region. And then from the 3 until 5 will be the third region. Lastly, from the 5 to 6 will be the final region. So first, integrate from negative 1 until 1 for the function negative x plus 1 respect to x. Second region, integrate from 1 until 3 for the function negative x plus 1 respect to x. Kindly take notes, in this part, the region will be negative. So as we all know, for the area, there must be a positive. So meaning that we have to locate a modulus in this part. Next, part number 3, plus integrate from 3 until 5 for the function x minus 5 with respect to x. Kindly take notes. Again, we have to locate the modulus because in this part, the area will be negative. So as we all know, there is no negative for the area. So we have to locate the modulus. Finally, plus integrate from the 5 to 6 for the function x minus 5 with respect to x. So for this part, no need to locate the modulus because the region is above the x-axis. Bracket negative x plus 1 to the power of 1 plus 1 over 2. Kindly differentiate the internal function and we will have negative 1 with the limit 1, negative 1 plus with the modulus. If we integrate the situation and we will have the same situation as previously, so we will have 1 minus x to the power of 2 over negative 2 for the limit 3 and 1. Next, for the third part, positive. If we integrate the situation and we will have x minus 5 to the power of 2 over 2. Do remember to differentiate the situation and we will have 1 for the limit 5, 3. Do remember we have to locate the modulus. For the final part, we have x minus 5 to the power of 2 over 2 for the limit 6 and 5. Kindly simplify the situation. So we will have 1 minus x to the power of 2 over negative 2 for the limit 1, negative 1 plus modulus 1 minus x to the power of 2 over negative 2 for the limit 3, 1 and the modulus plus we have x minus 5 to the power of 2 over 2 for the limit 5, 3. Do remember the modulus plus finally x minus 5 to the power of 2 over 2 for the limit 6 and 5. Substitute the value. If we substitute 1, we will obtain 0 minus bracket 4 over negative 2. Simplify the situation and we will have 2 plus with a modulus. If we substitute 3, we will have 4 over negative 2 minus, if we substitute 1, we will obtain 0. So for this case, the answer is plus modulus negative 2. Plus, if we substitute 5, we will obtain 0 minus, if we substitute 3, and we will have 4 over 2. So if we simplify the situation, and we will have modulus negative 2. Next, plus, if we substitute 6, and we will obtain 1 over 2 minus 0. So finally, we have 1 over 2. So if we add on the situation, we will have 2 plus 2 plus 2, 6 plus with 1 over 2. So finally, we will obtain 13 over 2 unit square. So here we are, and thanks for watching.